So today I have decided to start a new series, which, as you can see, that I'm trying to get myself in CCIE. Right now, because of the pandemic, the Cisco lab centers are closed in many places, and dates are hard to come by. So I decided that okay, um, even if it's not coming up, I should keep on repeating myself, and keep on doing the efforts to make sure that I understand the stuff correctly, and if I can help someone in that process, that would be a great joy. So based on that, I was doing a workbook, and I decided to share this with all of you by doing the labs together, and understanding the concepts, and seeing what we can achieve in that. So based on that, let me start all the nodes, so that you can see. And as you can see, I am not going to use any of the external stuff. I'm just going to use PNAT. This is a PNAT lab. This is not EVNG. Which this is the other, you can say, or the sister processors is same as IOU, but they have it in their own. So in this lab, what you can see, first of all, we have to understand we have to understand what we are going to achieve in this, and what we should be doing, right? So that's the idea in these lab setups, that not only we do the workbook, but we try to understand that what we are doing and why we are doing it, right? So that's the idea. So I hope that it will help us in understanding some stuff. So for example, in this lab, we can see that we have 4 switches, right? So we have 4 switches, and as you can see that we have connectivity between all of them, but not between switch 3 and switch 4. So definitely, without looking at the workbook, I can tell you, because I have done many vendors workbook, so I can tell you that they might be asking us to do trunk, and they might be asking us to do ether channels, so, and they might be asking us to map some layer 2 to layer 3, set up topology mapping from layer 2 to layer 3, or physical to logical. So these are the few things we are going to see in the lab, and on top of that, we might have other features, like we are going to see how a spanning tree is going to behave, how rapid spanning tree is going to behave, or how MST is going to behave, right? So these are right out of my head. This is what I think that we are going to see the labs for, right? So let's start. Let's see what the labs are. So tasks. Let's open the task, and let's see what we have in the task section. So in the task section, I can see that we have, and let me make it bigger, make it a little big, so that we can see. So we can see that we have the same topology. Then we have a logical topology, and then we have lab number 1. And as we were thinking, in lab number 1, we have to configure trunking, right? And the task 1 says configure trunk between switch 1 and switch 3. So it means that we have to create a trunk between switch 1 and switch 3. And by the definition of a spanning tree protocol, I don't know which protocol we are running on these. I don't know that yet. But hopefully we are going to run a simple per VLAN spanning tree, which is backward compatible to IEEE common spanning tree, right? Which has only one spanning tree instance, and Cisco implemented it as per VLAN spanning tree. So every spanning tree has its own, every VLAN has its own instance. So they are saying that we should do this, and they are saying configure the link between 1 and 3 as trunks. Switch 1 port 0 by 2 and 0 by 3 are connected to switch 3 port 0 by 0 and 0 by 1. Use .1q as the trunk encapsulation mechanism. So this is what they are asking us to do. So in that case, let's open switch 1. Let me see if my HTML mode is on. So the reason why I open HTML, because I do not want to open any external program, right? So I just wanted to have the terminal from within the from within the what you say from the program itself, rather than any external stuff. So I'm not going to use any external stuff, just for your reference, right? So let's move on to lab number 1. We are doing task number 1. So I'm going to put it here, and I'm gonna extend it if possible. Yeah, I'm gonna extend it here, and I'm also gonna extend it here. So as you can see right now, we have no configuration, and we are only focused in this lab on switch 1 and switch 3. Everything should be the default of it, right? So I hope that this video will come up as big so that everyone can see that. So if we as usual, right? So what I'm gonna do is that I'm gonna set up the initial configs. So I will say host name is switch 1 and no IP domain lookup, and I will leave the timestamps as is. I'm not going to change it, but I will change line console 0 logging in and exit timeout 00. And usually what I do is privilege level 15 on the console, and yeah, and that's it. That's what I do. Let's see on switch 3. So if we go here, we will do the same thing. So we will do host name of switch 3, no IP domain lookup, and we will be doing on line console 0, we will be doing logging in and exit timeout 00 and privilege level 50. So this is the basics of that, and I'm gonna save it, and I'm gonna export it with the Lab1, right? So that's the other thing which I'm going to do later on, and I will show you how I'm gonna do that, so that if we want to continue on base of that, we can continue, right? So right now there's no configuration set, there's nothing in there. So let's move on. So they're saying that we should now, if I look at show, because CDP is running by default, so if I look at the CDP neighbor, we have other switches connected, right? But we are not looking at them. We are only concerned with switch number 3, right? And you can see that these ports are coming back again here, so it means that the CDP hasn't refreshed itself. So if we do look, or if we can clear CDP table and then do show CDP neighbor, so you can see right now we have one switch, and in 60 seconds we're gonna learn the other one, so we'll wait for that. So same is true here. So let's do show CDP neighbor here. We see that we have switch 1 and the other switch. So this one got refreshed, right? So this is what I want you to see, that this one got refreshed. So sometimes you might see one switch multiple times because you have changed something on that one, especially the host name. That's the only thing we changed, right? So not yet, but we know which port we need to do, and they are saying that we have to do this on both the ports. So we can either use range command to do that, or we cannot do anything. We can do individual, right? So if you look at the spanning tree, but before looking at the spanning tree, let's see show VLAN brief, that how many VLANs we have. So you can see that by default we have only one VLAN, and all 8 ports are part of that VLAN, right? So if I do show spanning tree, just we see only one VLAN information, or if we have multiple, usually I run a command show spanning tree and then that particular VLAN. So right now it's all the same. So we can see that it is showing us that it's running IEEE, which is actually the backward compatible, or you can say this is spanning tree 802.1d, but the implementation of 802.1d in Cisco, if we look at show spanning tree summary, we see that we have the PVST mode enabled here, even though it's showing IEEE, right? This is implementation from Cisco side, right? So this is what we need to understand. Now everything else is, most of the things are off, disabled. We will see all of them in the future. So at the moment, what we want to do, if we look at back to CDP number, now you can see that we have switch 3 here back, right? So let's go on and let's configure the task number 1, which says configure interface Ethernet. So I'm gonna do individual on switch 1, and I'm gonna do all together on switch number 3. So by looking at, oh sorry, I just this. So let's do again. Show spanning tree, and if you look, because this is the root bridge, you can see that all the ports are in designated forwarding state. But if I go to switch 3 and focus on switch 3 is 0 by 1 and 0 by 0, right? So if I do show a spanning tree here, you can see that 0 by 0 is a root port, so it means that this is our root, and 0 by 1 is alternate block, so this one is going to be block. So this is just to let you know that by definition a spanning tree detects the loop between these two switches and blocked one port, right? So let's continue with our configuration. So interface Ethernet, and yeah, see, there's so many things I want you guys to understand before we do the configuration, right? So doing the lab just for the sake of doing the lab is not the objective of these lab series, right? The objective of this lab series is to understand why we are doing something, right? So if I look at the interface Ethernet 0 by 2 from the switch 1 perspective, and I say I want to know what are the switchport objectives. So you can see that right now this one is dynamic auto, right? And if I look at interface show interface Ethernet 0 by 0 switchport, so you can also see that this is also dynamic auto, and anytime it's a dynamic auto, they are static access, right? Because auto and auto is not gonna create a trunk. So right now they are not trunk because based on this IOL version, the default of the switch is dynamic auto, right? So and there are some which has dynamic desirable. So you have to understand that why we are doing this, and because this is auto, right? Because this is auto, it won't let me create this port a trunk port, right? So for example, if I go into interface Ethernet 0 by 2 and I say switch port mode trunk, it won't let me do that. Why? Because it says, okay, you want me to be a trunk, but you haven't defined what encapsulation I'm going to use, because this switch supports both. And let's see if it's right. Before I switch port trunk encapsulation, it supports both .1Q and ISL. If this switch supports only .1Q, even though if it is auto, it will let me convert to the trunk, and it won't say command rejected. It won't say that. Why? Because he knows that, okay, this guy wants me to be a trunk, and the only protocol I support is .1Q. There you go. You can do that, right? But in this case it won't. So I'm gonna say .1Q as per the lab. They want us to be .1Q as a trunk encapsulation mechanism, so we'll do .1Q, and then we will say switch port mode trunk, right? So by doing this, what's gonna happen is that if I look at show the same command, show interface Ethernet 0 by 2 switch port, you will see that now it is the mode is administratively trunk, operational mode is also trunk, and encapsulation is .1Q. Now we see the same command the other side, because other side is 0 by 0. We see that it's auto, and the operational mode turns into .1Q. Trunking is negotiated, and the operational is .1Q. So right now I can see that the trunk is enabled, but one side is static and the other side is dynamic. So that is not good. Every time, especially in your LAN environment, you should have everything is static. This is the norm that we try to keep ourselves out of anything dynamic, except protocols. We try not to use static because it's very administrative overhead is too much to manage all those static routes. So let's continue. So let's do the same on Ethernet 0 by 3, and we do the same switch port trunk encapsulation .1Q switch port mode trunk, and if you look, we have completed our task, what they're saying on switch 1. So if I go and look at show run interface Ethernet 0x2 or 1, so or not the 1, 0x3, so let's do 0x2 and 0x3. So you can see that now these are the two commands we needed for the trunking to work. Now we have to do the same on switch number 3, and for switch number 3 what I'm going to do is that I am going to do a range command of 0x1 and 0x0 and 0x1, and I will be doing switchport trunk encapsulation.1q and switchport mode trunk. So now you can see that what we did there a couple of times, we only did it once, right? So this is important in case you have to do multiple configurations, so you can do it quickly. The other thing which if you are not doing it statically, and if you are doing statically, it is good to shut down the one end, which I haven't done on the lab environment, but in the production environment you should shut down the one which is closer to you, where you have connected, if it is not a console connection, right? So if you are doing a telnet, you should shut down one end which is not the link where you are connected from, right? So you shut it down, you do your configuration, and then you power it up, because during the configuration in a live environment, in a production environment, you might create a loop which can cause outage. So it's better to shut it down, make sure that you do your configuration, and then continue. So if you look at the verification, because verify the spanning tree on switch 1 and 3 by using the show spanning tree command. So we can do that, show spanning tree. Because we are in VLAN 1, we can see that nothing has changed from the perspective of what we saw in prior to that one. It's still the same. And well, support on the root bridge and non-root bridge, so we have already discussed that. So if I look at the real thing, which is this one, is it saying that 0x2 and 0x3 is trunking, and right now because we have only one VLAN, so that VLAN is going on, and we should have seen the same thing here, right? So that and this is none, and the reason why this is none is because this one is blocked. So because it is blocked, there's no traffic passing by, right? So that is the idea of lab number 1. I'm going to stop here. I'm going to upload it, and then if you guys like it, let me know. We will continue on lab 2, 3, and I think I have 15 labs here. 15 labs here, which we are going to do on the same topology. So thank you so much. I'm gonna continue the other sides too. Have a good one, guys.